Hey students, this is lesson 4.2. In this lesson, we're going to learn how to identify and represent patterns that describe linear functions. Go ahead and do this review here, some of the important definitions for you to look at. I'll check back with you. All right, so we're going to learn how to represent some geometric relationships with expressions. And so look at the diagram here. What is the relationship between the figure number and the number of squares in the figure? How can this be represented? All right, so you might notice that in figure 1 we start with just an inside one and 4 pieces around the outside. And if you look closely in the second figure, there's that same object, but with another set of 4 around that. And then in the third one, we get that same inside one, and then 4 around that. And then another 4 around that. So one thing you might notice is that the figure is growing by 4 squares every time. And the number of squares in the figure, so let's just write a table here. So this is our number, figure number, 1, 2, 3, and number of squares. And that gives us, in the first one, there are 5 squares, and then we notice we added 4 more, so 9 and 13, and so on. So let's just make up a letter N for the figure number, and you might notice that we added 4 every time. So so we're going to multiply by 4, and if we like multiply 1 times 4. So n is the figure number, and so if we multiply 4 times n, so if I did like 4 times 1 here, that would be 4. 4 times 2 is 8. Notice that the number of squares is always 1 more than that, which kind of makes sense for the way our diagrams are drawn. We started with 1 and then we added 4 around the outside. So 4n plus 1 will give us the number of squares. All right, you try that. Okay, you've seen that one way to represent a function is with a graph. A linear function is a function whose graph is a line or part of a line. So linear means it goes up at a constant rate. So it creates a line when you graph it. All right, so representing a linear function, the table shows the amount of water Y in a tank after X minutes of being drained is the relationship of function. Describe the relationship using words and an equation. Well, first of all, let's cover the function part. Since there's an output for every input, it's a one-to-one relationship, it is a function. And we need to describe the relationship using words. So the number of gallons seems to be going down. It's decreasing by, and notice it's going down. It looks like minus 12 every time. So the number of gallons decreases by 12 gallons per minute. So we can get the number of gallons by we should also include that the number of gallons that we start with 440 gallons. And then the number of gallons decreases by 12 gallons per minute. All right, so now we're going to represent that with an equation. So X is our number of minutes, and Notice that we are subtracting 12 over and over again. So we can figure out how many times we need to subtract 12, which is the same as x, and just multiply that by negative 12, and then subtract that from 440. So there's a couple ways we could write it. We could just do 440 minus 12 x times, or we could do negative 12 times x first, and that would be a negative number, and add 440 to that. Either of those would work. All right, you try that. So I just want to talk about the second got it here. So we plotted those ordered pairs, and you might notice they don't line up in a line. And so question is it a linear function? To be a linear function, you would have to be able to draw one line through all the dots. And you can't do that. So, so this is not a linear function. Also, you might notice this, that right here at the input of 1, there's 2 outputs. If you have 2 outputs for a single endpoint, then it's not a function. So a couple ways of telling that. Go ahead and do the lesson check, and I will talk to you next time we meet in class about that.